Okay, just tell me when I can Yes, I'm on again. Okay. Well, welcome back. We had some technical problems, but we resolved it and we are back on track. So thank you very much, guys, to do it so quickly. Um, so basically, where were we? We were at the part that we discussed how the Cyber Resilience Act will affect various participants and users in the open source ecosystem. And understanding these roles and responsibilities are crucial to mitigate vulnerabilities and who's responsible. So as we can see, manufacturers are responsible for implementing security measures and ensuring compliance. Now, who's a manufacturer? We think maybe a manufacturer is somebody like Siemens or somebody like Apple. No, under the CRA, it means that also hardware and software are manufacturers. So manufacturers are the people, if you design, produce, or commercially distribute connected devices or software that incorporate digital elements, IoT devices, smart hardware, you are considered a manufacturer under the CRA. You are responsible for implementing security measurements, conducting compliance assessments, providing updates, and reporting incidents to your products. You see the manufacturer at the bottom. Then on the other hand, we have the open source software, and we can divide them in three categories. So we will have developers, we will have contributors, and we have non-commercial contributors that are basically exempted from the CRA. So if you contribute to an open source project that is not sold or directly distributed as part of a commercial product, then you are called a contributor. Okay, and then you are not a manufacturer. So this is important. So if we go through the flow chart, it means, are you contributing to an OSS project on your own? Yes. Okay, then it means then you are not in scope of the CRA. So it means that you contribute to the OSS. Basically, the people who are running the OSS, they are responsible for the CRA. They are responsible for the vulnerabilities. They are responsible that they have an OSS steward. They are responsible for talking to the manufacturers. They are responsible for that. So that's not in scope for the person who's a contributor. Now, if it's commercial or not commercial, if it's not commercial, then it's not part of the CRA. But if it's commercial activity, and that can be receiving money, that can be receiving money for funding an OSS project, if the money is more than the actual cost. It can be that you are part of a commercial product, then you're also doing a commercial activity. And if you get paid, of course, in this activity and you're not a contributor. So if you're directly monetizing the project, you see there a Dutch name, should be no, but okay. Then it means that if you're not directly monetizing the project, so basically you don't get paid directly from the project, then it means that you are supporting the OSS with intention of making this for the manufacturer a commercial activity. And if you are not providing support on that part, then you are not in scope. So your CRA will not be for you. But if you are, then you are considered an OSS, and then it means that you are using, that you are maintaining or contributing to open source projects without direct commercialization. In that part, you should be capable of saying, no, I'm not in scope. But if there is a commercial part in it, so if you, for example, provide services on an open source software project, and those services you get paid for, then you are an OSS steward. And that means that you are not directly responsible for compliancy obligations like security assessments, but you are for reporting and keeping track of the lifecycle management of the components that you put into the project. So the summary is like, if you produce or sell connected devices or products, then that means that you are a manufacturer and you need to ensure compliance. Okay. And if you contribute to OSS, you maintain or use open source or non-commercial products, you are not typically affected directly by CRA compliancy obligations unless you are involved in a commercial distribution. So this is the most important part. So if there's money to be made, then the EU says, okay, but then you have to make sure that you follow the articles of the regulation from the Cyber Resilience Act 2024, and to be precise, 2847 regulations in the EU. You see it on the right-hand side, top. And yes, so basically our part is that we help companies with virtual support on the CRA. And as you know, we talked about risk and threats and vulnerabilities and attack surface. And basically, to make sure that you have components, but you have a small attack surface, that means that the threats will have a very big problem to abuse the vulnerabilities that are on your component. So that's why we developed them up. And we say you're a visionary or you are a victim, because we see with all these components soon that everybody is using diverse databases with diverse vulnerabilities. They use diverse front ends, they will use diverse backends, they will use diverse orchestrators, and all of that will go, sorry, all of that will go into AI agents, collecting data and making queries on diverse databases. And how are you going to make sure that you're going to make this liable and that you know who is the producer, who's the manufacturer, and who will be responsible for keeping the components up to date. So basically, this is our solution. So we have basically all these OSI layers. So basically what we say is that you have all the OSI layers where you have the application components, you have the technical projects, you have the sessions, you have the presentations, you have the transport, the networks, and all these can come with their own vulnerabilities. And these cyber attacks, the only thing that we say that can be done if we are in charge of the data, then if people get their hands on a MAP client, then yeah, that's physical tampering. So on the right-hand side, you see, for example, the temperature. That will be a sensor that will not be capable of doing any encryption, but throwing it through the MAP client to the MAP server, it will connect there. And from the MAP server, it can connect to another MAP server. And from there on, you can have your agentic AI. It will be one way only. And that means that everything behind the MAP is protected and cannot be reached. And due to the fact that it not can be reached, the attack surface is 0. If the attack surface is 0, we don't care about the threats. Let me see. So to come back to this picture, basically you have to ask yourself, am I commercially involved in an open source software project? Is this an open source software project which we ask money for to support it or to give services around? Are there components, hardware components, software components that we use our open source components to make it a commercially viable product? then you have to be part of the CRA and the obligations around design and development responsibilities. If you are not sure, if your component is part of the CRA, what the workaround can be is that your open source component will be put into the Linux Foundation or the Apache Foundation, and that you can point that it's open source and that's distributed from those organizations, non-for-profit. And that would be my tip if you are not sure if you are part of the, that you have to be compliant. And this is not EU only, because, for example, if the customer is in the EU and your database is outside of the EU, still the Cyber Resilience Act is going to be part of this of your commercial activity, because it has an EU endpoint. And yeah, so even if you have a dashboard outside the EU, if people are connecting to it from the EU, then you have to be part of the CRA if you ask money for that. So what are the opportunities? The opportunities are big. I think with ML, machine learning, and developing secure software for that, global spending on generative AI is already $644 billion. And for global machine learning, it's $35 billion in 2024. And it will go to $47 billion in 2 years. And there are some projects around smart factories that could really benefit from open source, that could really benefit from making it secure by design. And we're talking about like real-time predictive maintenance of machines, distributing of onboard intelligence, for example, guided vehicles, digital twins, robotics, additive manufacturing, digital continuity. So the converse of production and business management information systems and their security against cyber attacks, if you start from the beginning and you make it a proper with the proper component, that you have the proper components in place, then your lifecycle management will be easy, your costs will be low, and you can standardize, and basically you can protect your hinterlying infrastructure instead of monitoring it, which I call the Matrushka effect, where you have to monitor a component, but the component that's monitoring the component needs to be monitored as well. So you will get this Russian doll that you pull out, and every time there will be a new doll inside. So we are basically based in Portugal, but we're virtual. And yeah, we're searching for partnerships where we can help to enhance cyber resilience and make sure that the products behind the infrastructure that we deliver, they are secure, and that they can be that they cannot be reached. So that was the presentation from my side. If there are any questions, I'm more than happy to answer them.
Thank you, Peter. I hope that we saw that people picked up after we went down from the air. So thank you for your presentation. It's always difficult for questions through YouTube, but I'm guessing that the people have liked your presentation. Let's hope some will flock towards also this project. Thank you, and we will be in touch. So have a nice day, and let's. Are you going to the party in Portugal or not?
I think you can't avoid it because it's a street festival. So basically, when you get out of the door, you only have to get out of the door. Yeah. So like we say, Studio Tilburg, stay in touch with the Dutch, no matter where they are.
Okay.
And we will.
See you.
Okay. Bye-bye.
Bye.
Bye.
Thank you. Sounds off.
Sounds off. Want we blijven op de... We stay on... Yeah.
Okay,
We
so-
are live. Thank you. Thank you everybody for visiting us again. We are here today with Ad Hendricks, one of the owners of One Optic, where our current studio is. And Ad is going to talk about ISMS, and that's Internet
Almost. It's an information
security
management system.
management system
So,
with open source.
with open source, of course.
Yes. So let's head over to Ad on camera 4,
Camera 4.
and then in screen. Yep.
First have to show presentation. And then I have to find somewhere there. Where's the cursor?
Ja,
The cursor, where's the cursor? Let me do it like this.
ik zag hem net voorbij komen. Yes. Oh.
Ah.
What's the shortcut?
I don't see a cursor, so that's very.
Second. And can I?
Yeah.
What you could do is, can you switch off to 4 for a second?
Yeah. So
Yeah.
Yeah.
I'll just take this HDMI out for the sake
Okay.
time being.
Fair enough.
Or bring this.
Yeah, there it is. There it is. Yeah, I see it.
Okay.
Go to this small icon.
Yeah.
I guess this one.
Yeah.
There you go.
You're good.
Now we can go on camera 4.
No,
Yeah,
go
well,
back.
There we go. So,
Camera.
in camera. Yes.
Yeah.
And the volumes.
Volumes on.
Yep.
yeah, are you ready to go? So there you go.
Yes.
Building an ISMS with open source. So, small agenda. First, I will give you a very short introduction. Then I will talk about what an ISMS is. Then I'll talk about the open source part of this presentation, and then conclusion. The very short introduction. My name is Ad Hendricks. I was born in 1974, co-founder of One Optic, like Eric said. One Optic is a data company. We are a classic data company. We are processing data, ingest data, put the data in databases, data clusters, a lot of SQL, ETL, and also we publish the data for our customers so they can analyze their data and do smart things with it. We are a company that builds open, high performance and scalable solutions, of course. We also do some software development, and we also have a service for onboarding and further developing existing software solutions. That is for companies that have their own in-house built software solutions, and we can build also on that. Customers, mobile operators, small and medium businesses with in-house developed software, and we are located in Tilburg, the Netherlands, in the south of the Netherlands to be specific. What is an ISMS? An ISMS is an information security as management and system. Yes. It's the core of the ISO 27001 certification framework, and it's about securing information in your company. And to specify the secureness of your data, we have 3 axes, if you like. Confidentiality: is your data still safe and not seen, accessed by people you don't want to? Is data is the integrity of the data still good, meaning that the data is complete and consistent and stuff like that? That data is not missing when you're working with it. That's the integrity of the data. And also the third axis is availability, meaning that the data is available when you need it. So basically, an ESMS, an Information Security Management System, it deals with these three items: confidentiality, integrity, and availability, CIA. An ESMS is basically a collection of documents and inventories that are related, and these documents and inventories can be easily improved, updated and adjusted in a consistent and reproducible manner, all for guaranteeing the CIA confidentiality, integrity and availability of your data in your organization. We have two items in this presentation, in this documents and inventories, with two visuals. The document is the small file-like icon, and the inventory is more like the list item, if you like. But still, first we start with a company. That's the basis of the ISMS, the company. And the company has a mission. The why. Why does a company exist? It's a very high-level statement for your company. The why statement for OneOptic is sustainable progress. It's very high level. And from that you can make a vision and also adjust the vision if it's all a vision. And the vision is more concrete, more specific, based on the why. And as you can see, the icons for this are the file-like icons, so these are documents. And these are part of the ISMS. That means that these documents should be available somewhere in your ISMS. So if somebody comes and is discussing your ISMS and he asks or she asks for your mission, then you can give him a document with the mission of your company and also the vision. Then we come to information security specific term, the risk appetite. And the risk appetite means how much risk the company is willing to take. You can imagine a very riskful enterprise, for example, in the financial world, where you want to make money fast and quickly. So then you can say, okay, our company is willing to take a lot of risk. And maybe another company also in the financial industry, for example, a bank, is not willing to take risk. So lots of measures have to be taken to reduce the risk in a company. So the appetite of the risk is something that's also documented in a document. You can see the file-like icon, and the company describes the risk appetite. More details on the risk appetite. A risk is basically the product of the impact and the likelihood of an event. And the impact of an event can be very high. A lot of stuff goes wrong. Maybe you have a big fire, often goes down, then you have a high impact. But also the likelihood is a part in the equation of risk appetite. For example, a meteor impact has a very high impact, if you can imagine, but the likelihood, as far as we know, is very low. So the risk of a meteor impact should be the product of impact and likelihood, and then you get something like medium or low. And you can categorize all these levels of risk from low to high. And then, this is risk appetite. The company has to decide what risk level is acceptable in the organization, the appetite. So red in this slide is we have to do something, not good, and green, we're good, the risk is manageable and all goes well, we can proceed to other stuff. The risk and the appetite. And again, the risk appetite is business driven. So not the cybersecurity engineers in your company decide what is risky and not risky. The business defines that, and security professionals have to carry it out. That's a bit short, but the risk appetite is business driven. Then each company has a context, an internal and external context. The context is, for example, the location where the office or offices are located. Also, the people who are linked to the company. Maybe the legislation you have to apply to, stuff like that. And with the context, you can create the first inventory in this slide deck, the inventory of the interested parties. And by the way, all these terms you see, the vision, the context, the inventory of interested parties, are terms that are one-to-one to be found in the ISO 27001 documents. Interest parties, customers, of course, are interest parties in your company, suppliers, personnel, but also the government and maybe other, for example, NGOs may also be interested parties for your company. And again, this inventory of interest parties should be available in your ISMS system. Then the core is the inventory of information assets. That is a list, if you like, of all information assets in your company. The ISMS is about information security, so it is trivial, it's logical that you have also a list of all the information assets you want to protect. These inventory assets, they should be confidential, have a good integrity, and also should be available when needed. So the CIA items apply to this list. And again, this inventory should be available in your ISMS. So when you have an auditor, a person that is auditing your company against the ISO 27000 framework, then he or she will ask for an inventory of information assets, and you should be able to hand it over. Then we have this group of context inventory of interest parties, and in this group you have the threads. So in the context of the company and in the interest parties corner, if you like, there are threads. Threads can be, for example, hacker collectives in China, but also fire can be a threat. And then the context is the building, and then fire may be a threat, maybe burglary may be a threat, stuff like that. You can think of a lot of threats that are threatening your company, and more specific, your information assets. Then information assets, which can be, for example, documents in a locker, or physical information assets, but they also can be data in your CRM system. Information assets can also be people. Yeah, your colleagues are also having information in their head, and also information assets. And all these kinds of information assets have vulnerabilities. People, for example, if they are an information asset in this presentation, can get ill or worse. So then something happens with the availability of the information in this information asset. For example, a locker may not be locked, so then it is also a vulnerability. Your office may, for example, not be secured enough. So all these kinds of things are vulnerabilities. So we have threats, we have information assets, and we have vulnerabilities. When you have this, all these documents and stuff in your ISMS system, then you can make an inventory of risks. Based on the threats, based on the vulnerabilities of your information assets, you can make a list of risks. For example, somebody comes in your office with tailgating, and he walks behind somebody else, comes in your office and steals something. That may be a risk. With the vulnerability, your office is not secured enough, and the threat is a malicious person on the street is going into your office. So this way you can make a list of risks for your ISMS. And then you get a good picture of what has to be done in your company to secure your data. see it here. All these items, the inventory of threats, the context, the mission and the vision, but also the risk appetite, all these items are tied to the inventory of risks. Because, for example, when the risk appetite says this threat is not very important to our company, then the linked risk may, for example, not be applicable for your company. And also, when you are busy on the risk inventory, you should update that once in a while, for example, yearly or every 6 months. Then you can think of new risks. So that is the arrow from the inventory risk to itself. Then you also have to make an inventory of incidents. And incidents are events when something went wrong. So when you have an event, for example, a malicious person walks in your office, that's an event. And if this person steals nothing, then the event was unharmful. But when the person who is malicious and comes in your office and steals something, then it has become an event. So an event on itself is not that terrible, but if something goes wrong, if you like, then it is an incident. And these inventory should also be available in your ISMS. And it also should be quite easy to log these incidents. But an incident can also be that, for example, we are a data company, Monoptic, and we publish some data to a customer, but we are too late. So, for example, a customer wants the data at 11 o'clock in the morning, and we publish data at 1 p.m. in the afternoon. Then you are too late. That's also an incident, because the availability was 2 hours too late. So you have an inventory of incidents and all the other inventories. And then you can also have an inventory of controls, and controls are the measures to reduce the risks. Because in the end, you want to reduce the risks. You want to have secure data, and you can do this by reducing the risks, and you can do that by applying controls. But before you can apply them, you have to know what they are. So this is the inventory of controls. The ISO 27001 has in itself already a predefined list of controls, 93 if I remember correctly. And these controls should be taken into consideration in your ISMS. There goes something wrong, I guess. Ah, there you go. Yeah. Oh. That was too fast. Yeah, I was talking about the controls. Now, like I said, all the controls, there's a list of predefined controls in the ISO specification. But also you can add extra controls to your inventory. For example, you are busy in a very specific business. You need extra measures to reduce risks in your company. So you can extend the list of controls that are predefined in the ISO specification. And for each control, you have to specify whether it is included in your ISMS. So basically, you are doing something with it, with this control. A control, for example, can be screening, that you screen your personnel. That can be a control. When you screen your personnel, then you can reduce the risk of personnel that is being blackmailed, for example. Or another control can be that you work on the locks of your doors of your office, for example, physical locks. So you have to state for every control whether it is included in your ISMS if you're doing something with, or you can also decide as a company to exclude a control. For example, you have a control that says something about using randomized data in test setups. When you're working with a software solution and you need data, you want to test it, you can, for example, use test data instead of production data. Then a control can be that you use very random test data. But for some companies, this is not applicable, so they say, okay, this control, randomized test data, we exclude it. But you have to justify it in the statement of applicability, being the list of all controls with the applicability statements. And also you have to say something about the state of the implementation of the controls, of the measures to reduce the risks in your company. This is a lot of paperwork, I know that, but if you have this in place, then I can guarantee you, you're getting in control of your information security situation in your company. So in the beginning it takes lots of work, I know that by experience, but later on you get the benefits of it. So, controls, then for the controls, in the right bottom we have an inventory of policies and procedures. So based on the controls, based on the measures to reduce risks, you can create a lot of policies and procedures for your company to implement this list of controls to reduce risks. This is a slide displaying the relations between the items I discussed a few moments ago, like the risk. You have a risk is linked to a threat. Control is treating, is reducing the risk, and control is linked to policies and procedures. So policies and procedures are the real world things your colleagues, your personnel has to do to follow to reduce risks. The other way around, sometimes you see in companies that they are implementing controls because that's good for cybersecurity, but there is no risk linked to the control. So then you are just doing the control because the control is there. So when you are implementing a control in your organization, there should always be a risk linked to the control. If there's no risk, then implementing control is nice to do, but it's a waste of time, basically. Okay, we're almost there. This is about the risk treatment. Like I said, the controls lead to policies and procedures, and with these policies and procedures you can reduce the risk. And by reducing the risk, you can go from the gross risk to the net risk. In this picture you see the risk appetite items again. The star in the red square is a risk, untreated. For example, a malicious person can walk in your company and steal stuff. There are no locks, the doors are open, and then the likelihood is quite high and the impact is also high. But you can take measures to make the likelihood that somebody gets in your office. For example, you can put locks on the doors, so then the likelihood of the risk that somebody steals something from you in your office becomes lower. That's a preventive measure you can do, and you can also make the impact of an event, of a risk, lower by correcting actions or delegating stuff. For example, you can take an assurance when stuff is stolen and you have an assurance, then maybe you can lower the impact of the risk. So the star at the top right is the gross risk, and after treating the risk you get to the net risk, and you see you go from red to yellow, and yellow in this slide is acceptable, but it can be better. The gross risk and the net risk. So that's a big schema. I've added one more item, the management review. It's also very useful if management reviews the whole system, all these inventories and documents once in a while. Typically that is done on a yearly routine, once a year. And then typically the CISO, the Chief Information Security Officer, makes a report with all these items and the states of the controls and the implementation and stuff like that. Get a nice report, and then the management, they can give their opinion about it and get some and give some tasks for the departments to improve stuff. But also this management review is also a document. See the document icon. It should also be included in the management system, the ESMS. Then the last thing for this scheme, and then we're done with this scheme, the PDCA cycle. I see that the C and the D are switched. It's the PDCA, the Plan, Do, Check, Act. It's also a very hype term, if you like. This whole ESMS, this whole system of documents, inventories, threat modeling, risk treatment, stuff like that. You have to apply a Plan, Do, Check, Act mechanism on it. I think it's known to most of you. You have to plan the actions to improve. You start left at the top. You have to plan actions, then to do these actions, then you have to check or monitor the results of your actions. Then you can evaluate the results of your actions. And when you have evaluated the results, then you can make new plans to do again and again and again, repeat, repeat, repeat. And then the main idea is you get better and better and better. You get better and better information security in your company. Also, this states that you have to start, just start, and in the beginning you have a lot of missing stuff. In our organization, yeah, we also had this experience. Oh boy, we're missing this and that. Oh, and if you think about it, maybe you are quite harmful over there, and you have some vulnerabilities over there. But when you start, and then over time, with this mechanism, Plan, Do, Check, Act, you get better and better. That's also nice to see in your company. That's an ISMS. Now the next item, how to set up an ISMS. Now, of course, you can buy a commercial closed ISMS solution. There are many to purchase: ISMS Online, OneTrust, ToolControl, Conformatix, Cyber Manager, Fanta, etc., etc. But this is an open source context over here, so we will do this with open source solution, of course. Based on the schema I pictured with all these items, these documents, and these inventories, you basically need 3 core components. You need a document store solution, you need a web-based documentation solution, and you need an issue tracker. Most companies, at least most IT companies, have an issue tracker they use for monitoring work and time tracking. So these are the basic 3 core components to build your own ESMS and the network of all the documents and inventories. Document store, you can use Nextcloud. I think it's also familiar to you. Yeah, I try to make a link to other presentations. Nextcloud, of course, you can put in Nextcloud the documents, for example, your agreements and SLA documents, but also meeting minutes, for example, board meeting minutes can be put in Nextcloud. That's the evidence. So when an auditor comes to your company and wants to see, for example, okay, you have decided this to implement this control, blah blah blah, then you as a company can say, okay, we have this meeting minutes as evidence in our Nextcloud system. It was then uploaded with this content, and then you have some story you can hand over to the auditor. But also other documents can be included, like DDAs, data delivery agreements, which is important for us. We have a lot of customers for which we process data. So for all these data processing stuff, DDAs should be there. You can read the slides, and also a nice feature of Nextcloud are that the files are versions in Nextcloud. And what we really like is the persistent linking feature in Nextcloud. So when you link to a file in Nextcloud and the file is moved over the system, the link still works. So that is really nice. And also you can, of course, configure the users and groups and stuff like that. So for the web-based documentation, we at Panoptic use Docusaurus. You can also use other web-based documentation environments, XWiki, stuff like that, MediaWiki, whatever you like. Use Docusaurus, it's open source. In Panoptic we put in the policies and procedures and processes and handbooks in the system. And what we like of Docusaurus is that it's a markdown system. We like markdown. Markdown is just what you need when you're writing text and documentation. And what is also a nice feature that the documents in Docusaurus are also put in a repository, in a Git repository. That's also nice for, it's small there, it's also nice for audit logs. So you can see the history of your policy, the history of your process document. And also a nice feature is that you can customize the theme, put in your logo, etc. For the issue tracker, you can use Open Project, an open source solution. You can see the features, you can put in your inventories in there, the lists of controls, the lists of interested parties, like I said, the personnel, colleagues, customers, suppliers, etc. etc. You can put in your tasks in there, dus see what the state of the work is and the implementation of the controls. And what is also important in Open Project in the issue tracker is that you can link the items. I had a slide a few minutes ago about a risk being linked to an information asset, being linked to a threat, being linked to a vulnerability. You can do this in Open Project. You can implement these links. So it's very then you get a very consistent picture, vision of your ESMS. Because then you can say, okay, we have this control is treating this risk, and this risk is linked to this information asset, etc., etc. You can do that. And you can put in the tickets and customization, etc., etc. And what is also very useful is an open API. And when there's an open API, you can schedule tasks as you see fit. Maybe you want to review your policies every 3 months, or every 5 months, or once a year. And you can, via an open API, you can schedule tasks, which is very convenient and useful. Conclusion. So with the 3 base components, if you build your ISMS around your issue tracker, which is also in place in your company, then it's more easy to make sure that all personnel in your company is doing what is needed to work with the ESMS, because then the issue tracker being part of the ESMS makes that people are working conform the ESMS. So that's more easy. When you have a separate solution, then people in the office need to learn a new application and have to copy data and stuff like that. So when you're using an already existing solution, it becomes more easy to implement the ESMS in your company. Then the second conclusion. I have 3 conclusions. That is the almost last conclusion. The statement of applicability, the list with the state and the applicability of all the controls in your company, the controls being the measures to reduce risks. And you have to say something about if they are applicable to your company, yes or no, and if yes, then what is the state of the control implementation. This follows from the system if you do it like this, because when all the risks and controls and information assets are linked in your issue tracking system, you can very quickly get an inventory and statement of applicability from the system. Because all the controls that are linked to a risk are applicable, the issue tracker also has in it all the tasks indicating the state of implementation of the control, and controls that are not linked to a risk are not applicable to you, to your company. So that is also a nice benefit if you do it yourself. And this also is a very important one, the last one I think. When you build it yourself with open source components, you are forced to understand what you're doing. Because when you buy a commercial solution, you get some consultants over the floor. They say do this, do that, and like this and like that. and then in the end maybe you are certified, but you're not really knowing what you are doing. And when you're doing like that with open source components, then yeah, everybody is more aware of what has to be done. These are the 3 conclusions. So yeah, I've think shown that it is possible to create your own ISMS with open source components. You don't need this fancy, expensive closed source solutions. And also working with open source is also more fun than with these closed solutions, I think. Thank you. These are my contact details. And thank you again.
Thank you.
And use this thing doesn't work.
Oh, it's fine.
We have digital claps as well.
Okay.
We have hands.
We don't hear it here, but
I prefer reclaps, yeah.
We have hands as well, but we like this.
you can stop it because it will go on and on and on.
Okay.
You have to press the 2 buttons at the same time on the.
No, I already stopped it.
Okay. So okay, camera 1, please.
Camera 1.
Art, thank you for
Yeah.
your
You're welcome.
very interesting presentation. Yeah, we had singing sound
Yeah.
around. Thank you for the presentation. We will have the next presentation in, well, 23 minutes. Presentation by Joaquin Seijo about Kubernetes for starters. And yeah, I hope everybody is still working hard on that project. Thank you.
Is
Hi, welcome everybody with my already third masterclass. So I am going to talk about the evolution of software development from scratch to no-code AI with some nice, I think, examples. Can you put on my presentation, please?
Four, right?
Four, and then in camera.
In camera. On.
Yes, so thank you. So we're going to basically see how we shifted in coding. So basically you could say that programming really started around 1952. So I'm guessing that nobody who is watching this or even sitting here with me at the table were there at that moment. 1952 is a long time ago, but basically most in the tree of the programming languages, a lot of programming languages branches started back in 1952. That's when and it was strange because what happened in the Second World War, England and the United States built their first computers. They used it to crack basically the German and Japanese secret code. And when the war was finished, they said, oh, we don't need it anymore. And they started demolishing the computers because it cost too much energy. And then it got back on track, and then something like 7 years later, then the first commercial computers, electronic computers come, because IBM already had mechanical computers long before that. And those computers, basically for that we used something called scratch coding. Why do you think that we call it scratch coding and not type coding? Why scratch coding? What is scratching? Scratching is with a coin on paper, like removing a silver layer to see if you've won a prize or not. That's scratching. So scratch coding refers to people who were programming by or punching holes in punch cards or coloring in on a punch card. So that's why we call it scratch coding. So basically we started with scratch coding. We mean we code everything ourselves manually without any help of the computer. So what's then help of the computer, right? So let's see what's help of the computer. When you use an integrated development environment, an IDE, and you have code highlighting, or you have functionalities that when you make a syntax error, that the software suggests what you should use, could we still say that's scratch coding, or is that already a bit of assist that there is available? I think the latter. It's already a bit assisted coding. So we are moving from a long time ago. We are moving from no assistance to a lot of assistance. So in the era of scratch coding, we could say we have traditional software development, full control, customization and transparency. Main challenges were it's time consuming, it requires deep expertise and high maintenance. So scratch coding, the rise of the low-code platforms. So that's something that some people have experimented a lot with this, like Yigisha, he has played a lot with Lovable, which is a low-code. No, it's not low-code. It's fully AI.
It's fully no-code.
Yeah, it's fully no-code. It's AI, fully AI this development. This low code, you should think about platforms like Mendix, Appium, Salesforce, Lightning. There are benefits. It's rapid prototyping. It has a reduced development time, and it's empowering non-developers. Now, you can use it for a lot of things. Internal tools, CRUD apps, basically apps to write, delete, and update tables in the database, and business process automation. Yeah, some examples. Mendix, Appium, Salesforce Lightning, that's all low code. So now we are in a time frame where we are moving from no code to a full AI. That's happening. And AI assisted tools like GitHub Copilot, Cursor, Manus, Leap. That's all happening. So how is AI changing the developer workflow? Now, auto-completion, code generation, and even full app creation. It's appealing to people. It attracts new type of developers, people who can't code, and suddenly get tools to create applications. So it's democratizing development, and it's accelerating innovation. That's for sure happening. Tools, GitHub Copilot, Manus, Lovable, Leap, all kind of tools to do this. But, you could wait for it. There is a but. There always is a but. What's the but? Vendor lock-in. Dependency on a single provider's ecosystem. So, what if you build an application, let's say with Lovable, and you become fully dependent on that application? Are there possibilities that the company behind Lovable can squeeze you money-wise? Are there possibilities? I think there are. Next, which often comes with the vendor lock-in, there's a limited portability. It's difficult migrating the code or apps to other platforms, or for very high costs. Next, there could be hidden costs, licensing, scaling, and unexpected limitations. So for some companies, there can be a strategy into this, meaning that they start their business, you start building your AI apps there for very cheap, you become dependent, and then 4 years later, when you want to renew your contract, they say, oh yeah, 4 times more expensive. Oh, you want your data back? No, it's not your data, it's our data. So that's the proprietary trap. So it's basically the same as with normal proprietary software. It's always the same story. Okay. Then, okay, the risk of proprietary tools. That's the risk of vendor lock-in, difficulty in switching platforms or vendors, proprietary versus open source, the lack of transparency, community support, and customization. There can be complex architecture. Black box systems can introduce technical debt and maintenance challenges. So it can be very nice to create an application, but later on maintaining it and combining it on an architecture level can be difficult, and code maintainability can be a problem. Now, like AI generated code may lack consistency, documentation, or best practices. Or what if you built an application with version 2 of a AI system, and then they are at this moment at version 6, and now you want to update your application that you built in version 2, with a version 6, and now it seems you have used functionality that's not longer supported, it then can mean that your entire solution will be unusable. So there are risks to this. Okay, so that basically I discussed already now, architectural maintenance challenges. There can be integration problems, complexities with existing systems. Debugging and troubleshooting in the black box environment is difficult. The long-term sustainability is also an issue. What happens if the vendor sunsets the product? They stop. And that's really an issue right at this moment, and not many people talk about this because we are in a market where a lot of companies, a lot of organizations are investing in AI, and I don't know if any of you has an AI subscription. It's the funny thing of YouTube. I can ask questions and I don't get answers. That's nice. Now, well, we have an AI subscription ourselves as Open Source Science. We have a subscription for 18 euros. We pay every month to Mistral, the chat engine. But I had a conversation with an AI specialist who said that if you would neglect all the money which is currently invested into AI, that the prices that the AI companies are calculating to really cover the costs should be 20 times higher. So if Mistral would really want to make money, they shouldn't charge us 18 euros a month, but they should charge us 360 euros a month. What does that mean? That means that we are building castles in the sky, right? There is a moment in time when the people who do all these investments in the AI companies are expecting a return of their investments. So prices should go up, or it should become cheaper for the vendors to deliver it. But that's really a problem, and that's why I address this with the long-term sustainability. That especially when it's a smaller company, if you are building your apps, let's say with Lovable, and what do you do if suddenly the company pulls the plug because they go bankrupt? Yeah, so that's really an issue. It's always an issue, especially with proprietary software. But with this really is, you're walking on a thin line because of this uncertainty. What will happen if suddenly the world decides that AI was nice, was cool, but not cool enough, investments stop, and what happens then? So, okay. Next, research. And this is a scientific research, and it's published, and they looked at developers basically, and developers were allowed to use AI, and basically the conclusion is that AI drops the productivity of experienced programmers by 19%. So that's shocking. So it's experienced programmers, not junior programmers. So experienced programmers are in fact faster if they don't use AI. So. Okay. So, next. AI is there. I don't think it's going away. But there's a lot of resistance. The last week I published a couple of blogs on our website, AI related. So I published a blog about AI and coding, which basically also consists of parts of this story which I'm telling now. And I published also an article about evolution and revolution, and what happens if new technologies see the light and come into the society. And for this, I want to tell a personal story. And you all see this nice picture here. So you see 5 men. They are in the city of Tilburg, right where we're sitting here. And on the right, the boy on the right is my great-grandfather. So that's the father of my grandfather. Now he is a special guy because he broke the tradition. The 4 men on the left, so left next to my great-grandfather, you see my great-great-grandfather, and in the middle you see my great-great-grandfather, and on the left you see 2 men. On the left, the most on the left is also a boy, I think, and they are brothers of my great-great-grandfather. So this is a family portrait. It's an ancient portrait. We think maybe taken around 1870. So it's a long time ago. So what has this to do with evolution revolution? Well, the 4 men on the left worked as Luddites, as weavers in a textile factory. And the textile factory was first manual. But in the Industrial Revolution, it changed to steam driven engines. And an operator of a steam engine is called a fireman. Yeah? That's what they call it. Now we call firemen people who put out fires, but those days a fireman was somebody who created fires. So my great-grandfather on the right, he didn't work in the textile factory as a weaver. He became a fireman. He became an engineer, an operator of steam engines. So that's funny. So the people were very afraid when the steam engines came. It would destroy all jobs. Factories would close because machines would do all the work. The milk would turn sour because of the heat. People would become crazy of the smoke. All kinds of stories happened. Still, the revolution came. Funny part is, my grandfather was a fireman, also an engineer of a steam engine, and my father was a fireman, a steam engineer of a steam engine, until he lost his job in 1967 because electricity came. That was also an revolution. People kept on working, right? It didn't change anything. I grew up basically in the age of computers. Did the people lose their jobs? No. New jobs came. Jobs changed. So, is AI going to make all our programmers lose their jobs? No. It will be just another set of tooling added to their work basket, which they can use to do their job. Of course, some jobs might change, some jobs might disappear, but other new jobs will come. So, and what you see always in a time when there is such evolution/revolution is that people are afraid. And people then come with arguments why it is bad. And I see this also a lot in the open source community. There's a lot of revolt against AI. I had a discussion a couple of days ago with a guy who said AI is bad, it costs so much energy. An open source guy. And then I said, but you use internet. Doesn't internet itself use a lot of energy? It does. So that's, oh, it steals. They steal all the data from all the artists, and they, yeah, okay, there's a, yeah, but still, it's happening. Will we stop it? Can we say that it's bad that it steals? Yeah, maybe that's true. It's bad that it steals. But that already happened. We should have thought before that we didn't want that. We didn't do that. It happened. So, change is there. Accept it. Okay. Let's come to a status quo. So, the AI is coming there. The AI has its negative aspects, especially when it's proprietary, that we already discussed. It can be powerful, the proprietary tools, but you need to understand the limitations. AI and low-code tools are assistants, they are not replacements, and open source AI tools can improve, not all threads, but will improve certain a few. So, if you at this moment still not follow us on YouTube, Mastodon or Blue Sky, please go over and scan our QR codes. Then you can start following us. Yeah? So,
over to the next presentation.
Yeah.
There is going to be Joachim's video, but he had some issues with the sound editing. That's where the issue was, but he's going to come back and give us a video in the next 15 minutes.
okay. So, yeah, okay.
Stay tuned.
Stay tuned. We see you in 15 minutes. some of the sound. Yes, thank you. Thank you all that you stayed with us. So for our next presentation, we have Joaquim Sejo from Portugal, and he's going to talk about Kubernetes, the operating system for the network. Yeah, Joachim works for SCi Labs. Senior DevOps engineer. So he has also a nice job. Thank you.
About Kubernetes, and I will try to give you a first look at what it is, what it looks like, and why it's been such a big deal in the 10 years since it appeared on the scene. A little background about myself. I'm Joaquim Sejo. I work at SCi Labs the last 80 years in cloud infrastructure. I've been working with Kubernetes since about 5 years, and before that I've been all over the place on data centers, server management, various kinds of programming, wireless networks and whatnot. To be honest, when I was offered to make this presentation, I had no clue what to say. Like many others, I have been using Kubernetes at work a lot, but I had never stopped to think about a definition for it. So, of course, that night before sleeping, I was looking at my roof, my mind totally in blank, and instead of counting sheep, I was trying to think about what is Kubernetes to me. And first thing that popped into my mind was, of course, what is probably the most common definition thrown around, which is container orchestration software or platform. And I thought, well, that definition is the canonical one, is the correct one technically, but it doesn't say much to a beginner. I don't think it's a good one in my opinion. Let me show you what I think someone who does not already know the answer to what Kubernetes is going to picture in their mind when they hear container orchestration platform. Now I know some might think here, dude, don't be silly, I know these are virtualization containers. Okay, so this is orchestrating then. Oh, so you also know what orchestration really is. Okay, so if you know all these things, you might not need to enter all this thinking about definitions. I know that I didn't. But it kind of proves my point that with container orchestration, we haven't got any closer to an actual clear image of what Kubernetes really is, especially for people that don't know it. I really think that orchestration is a bit of a lousy word to characterize software. I mean, you could argue that all software orchestrates something. But more importantly, there is something that is very rarely discussed about Kubernetes and the container thing. Containers are just means to get to an end. They are not the reason to be of Kubernetes. And I will get back to this important point later on, so try to keep it in mind. Okay, so then, how do we get to our idealistic magic definition? To finish my little story, the next thing I thought was, okay, so what do we use Kubernetes for? You know, what is the end goal? And the answer is super simple. We use Kubernetes to run our programs on the cloud. That's the end goal. We use Kubernetes to run our programs. And then I thought I was getting to something. This time, another arbitrary vague definition was titillating on the roof. And it was a definition so old that I wasn't even born after decades it was invented. It is one that everyone is super familiar with. And right then I fell asleep. Now, traditionally, operating systems have always meant one thing: That software that allows you to use a computer. The computer can be a personal computer, server, supercomputer, phone, or your fridge these days. Okay, that's good. But why did we want to be able to operate a computer in the first place? To run programs. That's actually all we do with computers. We run applications on computers, applications that do the actual stuff we need. Without applications, computers aren't that much interesting. Even an OS is a piece of software that isn't very useful by itself if we don't use it to run programs. So there is actual value in exploring this two-way correspondence between the concepts of orchestrator and operating system and subvert them to get a clear and intuitive understanding of what Kubernetes ultimately is. It doesn't matter that it isn't a formal understanding. If I can see Linux as a hardware and software orchestrator, I might as well see Kubernetes through DOS Crystal. It's not an operating system made for computers in the traditional sense, that's for sure. Instead, it is a different kind of operating system, one that was made for the network. Now, the next morning, the first thing that I did was looking up this on the web, because I imagined that the whole idea couldn't just have occurred to me. It sounded honestly too obvious in retrospect. And sure enough, there were plenty of material around discussing the concept of Kubernetes as an OS. And I also found, honestly, kind of expected it, a stream of mildly indignant counter-argumentation, with even some of the same authors that had started briefly entertaining the idea, turning the tables around right away, almost preemptively, with disclaimers the like of, well, you know, why you could see Kubernetes in this light, it is not a real OS, and you shouldn't kid yourself about it. That kind of stuff. And yeah, they are right. It's true that Kubernetes cannot talk to hardware like a real OS does. It doesn't have an actual hardware interface in the form of drivers. It doesn't have a kernel. It's not a computer operating system, 100%. And thus, it's very likely that voicing around all this Kubernetes is an OS thing might not be a very good idea. It might be like asking for long, tedious arguments on how that definition is wrong, from a hardcore technical perspective at least. Now, if you're willing to enter those discussions though, I will tell you how I'd respond. From this point of view, the hardcore technical counter-argument is focusing on implementation details, i.e. the how of an operating system does what it does and not the what. Many of the hardcore technicians may also be fans of the Python programming language. One language that embeds at its very core a way of categorizing things called duck typing. Now, duck typing relates to a not logical test called the duck test, and it goes like this.
If it looks like a duck, swims like a duck, and quacks like a duck, then it probably is a duck.
Now, if we apply duck typing to Kubernetes, you might find that it is indeed very much like an OS. For example, let's take Linux in particular to talk about an operating system in the traditional sense. These are the things Linux does and the core functionalities people take for granted with it compared with Kubernetes. And as you can see, the one big difference here lies on the first row, the underlying platform that each kind of OS is dealing with. The argument I talked before focuses mostly on that first row and points out that architecturally speaking, i.e. the internal design and how all the internal pieces work together, a traditional operating system and Kubernetes are totally different beasts. And not that it's wrong, it's just that that isn't the perspective we are using here. If you focus on all the other rows, functionally speaking, both Linux and Kubernetes start to look awfully similar. A little note, whenever I say Linux in this talk, you can take it as shorthand for traditional operating system. It's shorter, it's what I use, and I hope you do too. Going over quickly over the rest of the rows, Linux lets you manage programs, install your programs, run your programs, access them and uninstall them. And Kubernetes also lets you do exactly the same thing. You can install programs on Kubernetes, run them, access them, and uninstall them. Linux supervises those programs while they run, and Kubernetes also does that. In both cases, this is so programs while running don't hang up, don't eat all the resources available, that kind of stuff. Managing data is another thing that a traditional OS like Linux and Kubernetes allow you to do, because without data, programs aren't also much interesting themselves. So you can input data on the system, organize your information, transform it, process it with the programs, and delete it. Now, in the case of a traditional OS like Linux, RAM memory, disks, file systems, those things are managed directly via hardware drivers. In the case of Kubernetes, it will delegate the low-level functionality to the actual OS. For the case that supporting multiple concurrent users, well, the functionality here is exactly the same. You can have multiple concurrent users and programs both in Linux and Kubernetes. And controlling access is another feature that we take for granted from an OS, in the sense of controlling which users can perform which operations on which programs and data. And both Linux and Kubernetes allow you to do exactly the same. And this is the core functionality that we take for granted from each type of OS. And now we're going to talk about the differences, which basically boils down to this. When running our programs on the hardware of a single computer, we care about different stuff than when running our programs on a fleet of computers, i.e. a network. Now, before I enter on detail about the differences, I have to clarify a term I'll be using a lot with talking about Kubernetes, which is node. A network, any network, not just computer networks, is made of nodes, which are the things in the network, and lines that connect the nodes, also called network connections or links. In the case of computer networks, well, a node is a computer. That's basically it. It's a little bit more nuanced than that, in the sense that on a computer network there are nodes that are special kinds of computers, things like routers, switches, and yada yada. Ultimately, it's all specialized types of computers. It doesn't really matter. For our today's presentation, we'll just think of nodes as the computers we're running Kubernetes on. Also, by the way, from the point of view of Linux, Kubernetes is merely a bunch of quite normal programs. They're really nothing special, and they do the same kind of work that other programs that aren't Kubernetes do. But anyway, nodes equal computers running Linux and Kubernetes. Now, quickly going over how Linux and Kubernetes differ, which basically goes back to that first row on the previous chart. So regarding the memory, which is managing virtual memory, preventing clashes, protecting memory areas, sharing memory, well, Linux does it directly because it manages the RAM chips. Kubernetes, while it has the ability to allocate RAM for different programs, it does so by delegating the functionality at a low level to Linux. Same for hardware I/O and CPU arbitration. These things Linux does directly, and Kubernetes delegates the functionality at a low level to Linux. Now, when going over the things that are related to running programs on our network, on the opposite, Linux doesn't do any of that directly, and it's Kubernetes who takes the charge and does these things, operating multiple instances of program as a whole across a network, doing network load balancing, failover, upgrading a program across a network while maintaining availability, even when you have multiple instances of that program running simultaneously, migrating workloads across nodes in a network, all these kinds of stuff. Kubernetes does it natively, and Linux doesn't care about that. And now we are ready to discuss why are containers so important for a network OS, as to justify it being defined as a container orchestrator. When running our programs on a single computer, the programs are placed directly in RAM by the kernel, which also uses the file system to load any libraries the programs need. The programs ask Linux for the hardware resources they need to use, they do their job, then go, and other programs are started and the cycle repeats. When running our programs on a network with Kubernetes, the programs are placed on the nodes by Kubernetes. They are assigned the CPU and RAM by Kubernetes, delegating the details to Linux. Kubernetes gives our programs access to volumes on those nodes for storage, also delegating the low-level details to Linux. And the programs do their job, and other programs are started and the cycle repeats. So why containers? Because containers include not only our program, but all of its runtime dependencies like libraries and configuration. They are kind of like a tiny virtual OS, so they make it very easy to do all these things such as network migration, because you just copy the container over the network and spawn it on a different node. So what do containers bring to the table here? Well, they bring easy packaging, easy definitions, and therefore easy network migration and failover. That's the why of containers. In hardcore technical definition, a container is virtualization. It's a way to treat a set of programs as if they were running in their own separate instance of the Linux OS. The containers have their own little file system, their own separate list of user and group IDs, their own separate list of network IDs, but in reality it's just all real file system and IDs. It's just Linux on the back simulating that they are separated, so you get the illusion of a virtual Linux. Containers are called operating system virtualization, and this time I do think it's a good definition. Since containers are easy to move around on the network and can be started and stopped quickly, and they aren't using lots of resources, they are ideal for Kubernetes, and that is where all the container orchestration thing comes from. So the takeaway here is that even though I will smile and avoid calling Kubernetes an operating system, after I finish this presentation that is precisely what it is to me. The fact that it orchestrates containers is just an implementation detail, a very important one, but it's not the reason to be.
Thank you, Joachim, for your nice presentation on Kubernetes. Thank you.
Yeah, that's good. Hello, so welcome back everyone. We've had some fantastic masterclasses by experts from across the world, from India, from Bangalore. We've had speakers from Mumbai, we've had speakers from Portugal, we've had speakers from Germany, we've had speakers from Netherlands. And right now with me, we have a panel here to answer a few questions that keep coming up in the open source world, especially when we travel around universities and companies keep asking a few questions. So I have two experts with me. One is Eric Mols himself, and then I have Bram. Bram is a senior account manager with our group of companies taking care of some of our larger clients. He's also born with open source in that sense. So these two gentlemen are going to answer a few questions that is quite relevant to what the open source world or the non-open source world asks, on questions. So if I can ask you, Bram, if you can start by giving me an example of a company shifting to open source.
A nice example. Well, first of all, thanks for inviting me. I think 3 weeks ago, little construction company came to me and they asked me like, hey, we want to go open source. They heard about what Trump did with the international court, like banning some of the top jurists there, and they said, no, we don't want to take that risk. So the first thing is you really need to look at what are their requirements. Every business, of course, has its own way of doing things, and it's important that your software matches those processes. So we start off with making a checklist where we go into their processes and we say, okay, you need, for example, they needed to share designs for buildings, but they also need to keep a good version history. So in that case, Nextcloud was very handy because every time you update a file, it will show which revision you're looking at. And then you can always tell your client, oh no, you're looking at version 1.2, we're already on 1.3, here's the latest version of the file, and you can just easily share it, and they can also put their comments quite easily with the file as well. So that was one of the first things they did. Second came their accounting. Odoo, of course, is very mature in accounting these days, so we suggested to shift them over to Odoo. And then they could also use that, for example, for their project management, because Odoo, of course, comes with a very large amount of modules. So I made a selection of 5 modules that were an absolute must for them. And I think within 2 weeks' time, they were starting to run on open source. And of course, the biggest challenge comes afterwards, because you need to adapt to new software, you need to learn the ins and outs, where's the button I'm looking for, how can I publish my articles. So yeah, we trained them, and especially the aftercare went quite well. They were asking their questions, we were giving the answers, and they're now happy and fully open source in their office.
Fantastic. So how do these companies, balance the cost of savings with respect to an open source adoption? What do you think the return on investment in time, or is it cheaper to go into open source? How does it feel for them? How does their finance CFO look at after you've implemented the open source project, say a year from now? How do they look at it?
It's always a huge shift in your mindset, because you're used to paying licenses, you're used to paying hosting costs. And then when working with open source software, of course, the licenses, they become less of a burden. So you don't have the sudden price increases of Microsoft 365. You don't have for example, the license model that Odoo Enterprise uses now. They put 9% extra on top. And they don't communicate that beforehand, right? They just send you an email, and this is your new price for the coming year. And if you don't...
Caught off guard in a way.
Yeah, you're caught off guard. Yeah. And when working with open source, you shift those license costs, so it's not a total saving, because of course you're going to need some new training. It's a huge upfront investment, but as soon as you are up and running, you will see that the running cost, so that the total burn rate is starting to decrease over time. And especially with upgrades, you don't have to pay for each new version of the software. No, you just get it up until you reach a certain size. Like I believe Nextcloud was 250 employees, that the limit was, and then even then, looking at the license cost for Nextcloud as opposed to Microsoft 365 was 10%.
You also have some experience working with the Dutch Open Source Business Alliance, the DOSBA, right?
Yes.
And so it's kind of the government moving into open source software. What is your experience with that? Can you share a few things? Because I had this for my presentation, digital sovereignty, and with your experience, do you think governments are moving fast enough, or should they move faster? How's your experience with that?
Governments, they tend to get stuck in their own politics in that sense. So they make a decision, they want to go open source. We did that, I believe now 12, 13 years ago in the Netherlands. They wanted to shift from Microsoft Word, Microsoft Office basically, the entire suite. And they wanted to switch to LibreOffice. They were making a selection at that point. Was it LibreOffice, was it OpenOffice? And as soon as the decision was made, you see that the internal politics go and people don't like to learn new things. So the project over time, it got less and less important. And then in the last, I think 3 years, we see a huge increase again in the interest in sovereign software. Which actually causes the government to have to reinitiate these projects, of course not moving the quickest. But once they do have a workable model, they can roll it out, and you just start with a small local government and you go to the province level. Maybe you can get now for example, Binnenlandse Zaken, so internal affairs, is now focusing on getting OpenDesk running as soon as they can, which is a new German initiative. And you see that now they are running instead of walking. So
Fantastic.
it's picking up pace.
I think in India also they're picking up a lot of open source initiatives from the government. But again, as per my last slide, every policy needs to be enforced. So I think that's where most governments are lacking, because they cannot enforce it overnight. So it takes time for them to enforce
And
it.
it's difficult for the people who use it to change.
Yeah, that's
And it's easy for us to talk about change. If you're familiar with computers, you're familiar with programming. Oh, what's a new program to me? But if you are, let's say, you are in your 50s and you just managed. Now you finally have the feeling that you dare to touch your documents in Microsoft Office 365. You're now familiar with, blue is a text document, green is a spreadsheet, and that orange thing is for my presentations. And now some person walks into your government agency and says, hey, we are going to switch to Nextcloud, which is a fantastic solution, of course. And for us, this is easy to do it. But what if you just managed to learn this, and now suddenly somebody wants you to change that again? I think that's maybe even the biggest struggle we have to come over.
right. I have another interesting question for Eric, especially. What are the key legal, security, and compliance challenges that businesses face while they switch to open source? Because this is a question that I don't want to mention the name, but the head of India's largest biopharma industry security division called me up to say, we want to switch to open source. Can you guide us?
Well, what's the biggest legal issue, right?
Yeah.
So the biggest legal issue is with proprietary software. And people forget that. They say, we use proprietary software, we have signed a contract, so we are good. The issue, of course, is what if you want to audit the software? What if you want to research to see if the software is really compliant to all the regulations? You cannot do that because the software is proprietary. So with open source software, you always can hire somebody to examine the source code and to see if the solution is compliant with the regulations.
Yeah, I think that's a good measure, because that's also recently, one of India's largest oil companies was shut down overnight from the US because of the oil import sanctions that India faced from the US, right? So this kind of now is turning a new wheel now in India, and the governments really want to switch. All these big corporations, they want to move to open source. So there's going to be a huge influx of employment going to be created within the country as well for open source software, for engineers, because of course you need the skill sets. Right now, you go to a university, you go to a college campus, less than 3% of people actually know Linux, for example.
And of course, universities can change, but that will take lots of time.
Yeah.
They could come to us, and we could help them with our open source curriculum to adapt faster to these changes, so that they can gain also an upper hand in the own education market, because then they can show to other educational institutes that they are moving forward.
Yeah, and I think, Richard, you really hit the nail on its head there, because you see now a lot of big corporates want to shift to open source, but now the thing is, they have been neglecting it for years. People have been trained on Microsoft, they have been trained on the big ERP systems, and now there's this sudden urge to switch. So now you run into a barrier of there's not enough people who can actually support the software. And this has been an ongoing issue, not only for businesses, but also for the government, is that if 95% of IT companies only support proprietary software, then making that switch to open source becomes increasingly difficult, because not only do the employees have to be trained of the companies or of the government to use that software, no, the people who have to implement it also need to learn different software, and it's in terms of the way you build it up, it's a very different way of thinking.
And we can also help there, because we, for example, if your government organization or your university would want to switch to Nextcloud, we also have trainings for Nextcloud usage, and in India we can even help facilitate to set up Nextcloud instances, so you can move forward.
Right. There is also another question. What are the new open source initiatives that, this will be the last question because we have to wrap up this session, but what, to both of you, what are the new projects, initiatives in the open source that you think a student or a university could follow?
That's an interesting one. I think there's, I can name a long list of good software solutions that come from open source, and of course it's up to every individual business to figure out what their needs are. But I think there are a few new initiatives. Zendesk in Germany, they have come out with a new selection. So they pre-select a bunch of open source software like Nextcloud, like Open Project, but also like Griffin for taking notes. And they bundled it nicely, and they made it entirely Kubernetes ready. And they also released it as an open source project. And they're now focusing mainly on government. But starting 2026, they will also start to onboard businesses. And they want to do that via resellers, but still it's very interesting that you can get a bundle of software. Everything is nicely integrated. You get one dashboard. All apps have a similar look and feel, so that you don't have to face the burden of, oh, I'm using 10 different apps and it's, where is everything? No, it's now more, okay, we get the pre-bundled software solution. You can just plug and play what you want. You can basically just check which softwares you want. For example, do you want Matrix with Element for your communication? Oh, it's literally enable it in the YAML files, and you can start to use it. And it will automatically deploy, so it becomes easier not only for the IT companies to implement, but it also becomes easier for the users to use, because everything feels cohesive and complete. I think these are the projects we need to watch, because these are the guys that are going to get the software to market.
Yeah. So for me, a couple of projects come into my mind. A lot of we already discussed in some presentations. Of course, Lamiri, a full convergent desktop environment, so that we can have one desktop environment on Linux from your smartwatch to your television. So that all apps will automatically adapt to the form factor. That's a very interesting process. We also discussed about RISC-V as a new computer processor architecture, which is fully open source, also open hardware. That's also, I think, an important development. And what was I thinking else? RISC-V. Meaning.
What kind of languages do you think students can
Oh,
focus on
yeah.
now in terms
Yeah,
of languages?
that's
Because
of course.
software is built on a language. So what kind of languages?
So that's what, that's like the Rust programming language is also making, it's gaining a lot of popularity. Yeah.
I think Google's Go also, because you see it getting implemented. Kubernetes is for large parts written in Go. Now, for example, Nextcloud is also working together with OpenCloud, and they rewrote a lot of the PHP code, which is now kind of an old language. And they rewrote it all in Go, so the interface becomes much faster, interaction with the backend as well. So I think
I would also suggest Qt-QML, because a lot of these screen infotainment systems, machine systems, or the screens of the machines, right? It's called human device interface, right?
Yeah.
So those interfaces are all written in Qt-QML. There is this huge demand for Qt-QML engineers. The other day I was looking at an India job portal just to see what kind of demand. The huge demand, and they're paying top money for Qt-QML developers with Rust, C++ background, and what you
it's
mentioned,
of
Go.
course logical when we go back in time. If we go to 2001 and we were basically programming for computers.
Yep.
Since 2008, smartphones and tablets entered the fray. But then development came, and now if my wife will message me, the refrigerator broke down, please buy a new one, then it will be interesting if I will be able to find one without an internet connection, if I don't want that.
Yeah, that's right.
So all appliances, and that's the revolution of the Internet of Things.
Yeah, that's a funny thing. We bought this cooktop, right? The cooking top. It's completely touchscreen. The entire thing. It's got a digital dashboard. It's got temperature reading sensors. It's connected to the internet. I can operate it from the house, from my office. It's insane. I mean,
I have a toothbrush with internet connection.
right?
oh, the I/O from
Yeah,
Oral-B, yeah. No, but this is a logical next step. I mean, a few months ago we finished up. A friend of mine, their parents, they were building a house, and they asked me like, "Hey, can you help me out?" Because they have solar panels, they have smart appliances like a Samsung dishwasher, and they wanted to connect everything up. So they're using a very nice open source project, home automation it's called. We managed to connect all these devices up to one single like home server, and taking in the variable energy rates, they could also like charge the battery when it was the most efficient.
It's most intelligently.
To make the most intelligent usage of power within your entire home as possible. So the dishwasher would turn on when the energy was cheap, but also, for example, your warmtepomp,
the heat pumps.
Heat pumps, yeah. So the heat pump, that's like thermal energy storage, right?
Yeah,
so you heat it up, you preheat it when the energy is cheap and when you have a lot of energy coming from your solar panels, and then you would discharge it later on. And this is connecting. This is making your entire home smart. And it's especially here in the Netherlands and in Germany, I see a lot of people shifting towards these smart homes.
What we see, I think the general conclusion of this is more and more appliances are coming, which need to be programmed. That's going to
skyrocket.
It's skyrocketing. Everything will have an internet connection. Everything will be programmed. It's even coming into to your own body. You have people who have a
insulin devices,
an insulin device
all
in the
controlled
body, a
from,
Cochrane implant with an internet connection.
It's just happening. The world is just changing so fast on connected devices.
And what do you think about wearables with an internet connection? Your smartwatch. I am wearing this headset, and the entire day. Why? Because it doesn't cover my ears and it gives me information when something is happening on my phone. There are companies, and I think Sony in Japan is working on contact lenses with a display in the lens, so you can see information while just looking through. Terminator is really coming. That's interesting.
Even for vehicles, we have a specialization coming in our 4th year program, which is called software design vehicles. So gone are the days when we thought the engine is going to drive a car, but now software is going to drive the car. So for listeners across India, for this concluding panel discussions, it's just these guys just opened up a can of worms in terms of what are the possibilities that you guys can get into. It's too vast, but to learn these technologies right, you have to be in there right now, and this is the time.
Yeah, and sometimes people are telling, but AI is coming, there will be less programmer jobs. It will become easy for programmers. But the amount of technology that needs to be programmed is growing so fast that I think we still need more and more programmers.
Yeah.
And if you combine this knowledge, what I just told, with the expected decline of the working population in China, with China is, well, it's expected that the next 30 years the Chinese population will halve, going from 1.3 billion to 600 million people. That will have also a huge impact on
manufacturing and
so the opportunities this moment to develop your knowledge into open source are huge.
Huge. Yeah, I was looking at the figures just to close. The figures in Europe by 2034, they need 1 million programmers. 1 million, right? In India, with this push from geopolitics and India trying to be digitally sovereign, they're going to need 4 million programmers, right? Because that would be not enough for the size of the country and the population, right? And the requirements of businesses. America itself would need about 500,000 developers in the next 5 years. So it's just exploding, guys. So this is the best place to be in right now. And with that, Eric, if you can, if you can just mention to the teams watching us, what is the next agenda and how we can follow up.
I have my slides ready for that.
So like a conclusion.
If we can jump to camera 4, then we do a conclusion of our hackathon and all our masterclass presentations. I think we had a quite interesting 2 days with a lot of presentations, a lot of them of course connected to the technologies of the problem descriptions where the students are working on. The last figures I got was that we had 71 teams participating in our hackathon, so we are quite anxious to know and see what they have cooked up with. Maybe there are some very interesting results companies and projects can directly implement and use, which would be extremely interesting. So students, you still can continue till 13th September. 13th September you will get a link via your email address, which is registered with us. If nobody from your team is registered with us, then you should complete your registration, and that should go through the Reva University.
Yep.
we need that email address. So we send a link to that email address. In that link, that will point to a form on our website where you leave all the vital information that we need. That basically is, of course, your name, your email address again, your team members, their email addresses. If you are participating from a university which is not yet a customer of Open Source Science, we will ask if you will fill in the name and email ID of your professor or your dean, so we can contact them directly. And of course, last but not least, your repository link, which either could be your GitHub, your GitLab, or your Codeberg link, where we can find the project. So then our jury will delve into the projects which are delivered, and of course also filling in this link will give us the possibility to generate certificates.
Yeah.
Right?
Participation certificates
Yeah.
for the team members.
Yeah, which could be very interesting. Then we're going to look at the results. The jury will delve into that, and we will do an announcement of the shortlisted teams on the 19th of September. Then the teams, the shortlisted teams, will have to do a presentation before the jury on the 20th of September.
No, that's going to be, yeah, correct.
Yeah. And from that presentation, we will select the winners. And then later on, there will be an award ceremony. That date will be later determined. That is dependent on if we're going to do the award ceremony partially online or in person. So depends on when somebody from Open Source Science travels to India, or if not, then we do it online. Yeah. So thank you all for your participation. Also from the team here, from the REVA team, from Open Source Science, from OneOptic, and very much success with building your open source solution, and hopefully we will see some of you as a student, or others maybe as an employee in one of the many companies. Bye.